Good evening. We're so glad to welcome you to a very special event in our Wednesday night live presentations. Since COVID has hit, we haven't had too many of these, but we're kicking them off this fall. And tonight is a very special presentation. We are pleased to welcome Dr. Jim McClintock, who is the endowed University Professor of Polar and Marine Biology at UAB. And tonight he's going to be sharing with us a very interesting title, From Penguins to Plankton, the Impacts of Climate Change on the Antarctic Marine Communities. Dr. McClintock has been at UAB some 33 years and has been to Antarctica at least 25 trips, published over 290 articles, and basically a who's who if you look at all the publications that have cited him or included articles of his. So we're very fortunate that he's in our community and can be here with us live tonight. You know, it's very interesting that the Bible tells us that we're to have dominion over the earth, but we're not to abuse it. And I think there's a great message in that for us in these days when there's so many things happening that we have to be good stewards of what God has given to us. So we're looking forward to this presentation, and we just want to have a word of prayer before we begin. Dear God, we are grateful to you for all that you have created, and you have given us great responsibility in this world, in this earth. And we just thank you, Lord, for Dr. McClintock and for bringing him to us tonight. Pray your blessing upon him and his work at UAB and his research. May you continue to watch over him. And we do pray about this whole situation with climate change, that we may have greater understanding and be able to move in a direction whereby we can be good stewards and be proud that we have taken care of what you've given to us. So we pray that this will be the case, and we just ask now that you bless this time as we share it together. In Christ's name, amen.
The next slide. There we go. The next slide. I will never forget, as long as I live, the first time I put my wetsuit, dry suit, on and dove through 8 feet of sea ice and floated down through the water in Antarctica. It was kind of like entering the Sistine Chapel, just floating through space. And I looked down, and the floor of the ocean of Antarctica was covered with life. As far as you could see, sponges and corals and starfish and sea urchins. And for 10 years, I worked at McMurdo Station, the largest of the US stations in Antarctica, studying all sorts of aspects of the ecology of these marine organisms. But I used to hear about a place far away called Palmer Station, up on the Antarctic Peninsula. And it was spoken with reverence. It was a Shangri-La, a little station perched on the Antarctic Peninsula. Well, I was very fortunate in my research that I got to go to Palmer Station and carry out work. And I have been there now for 20 years. Palmer Station, nobody told me, is in an area that is going through dramatic climate change. The Antarctic Peninsula is changing quickly. And that's what I want to talk about today with you, is to tell you the story of how this change is occurring and who's being impacted and what we can think to do about the future in this regard. So, if you go back and look at National Geographic in 2006, you can see that the concentration of orange in this image, the warming part of our planet, is to the north. It's largely an Arctic story. But this was in part because we hadn't really looked closely enough. When scientists began to look at Antarctica carefully with satellite data, ground station data, not only was the Antarctic Peninsula warming, but the entire western portion of the continent. Now remember, Antarctica is huge. This is a continent the size of India and China combined. Okay, so it turns out that we also have evidence that the eastern side of Antarctica is beginning to warm. If you look at those little orange dots along the edge of the continent, what they represent is warming or melting that's occurring with the ice shelf. And the ice shelves are melting both on the west and the east. So we know that the Antarctic Circumpolar Current, the world's largest current that goes around Antarctica clockwise, is beginning to warm and affect the ice shelves. Well, how much warming are we talking about? Well, if you can see the little arrow there, it's pointing at my station, Palmer Station, on a little island. And there's another station near us that has recorded air temperatures for about 60 years. And if you plot the daily air temperatures over 60 years, you can see that the air temperature has increased about 10 degrees Fahrenheit over that 60-year period. That is amazing. That makes this region of our planet one of the fastest warming areas anywhere, and really quite similar to what you hear about in the Arctic, where the warming is very rapid and we have lots of the ice is melting and you hear the stories of polar bears having trouble. All right, so what does this mean? What does this warming translate into if you're down there yourself? Well, I can tell you that 20 years ago, when I used to go to Palmer Station, about once a week, I would hear a huge crashing sound, and the glacier behind our station, the Mar Glacier, would have calved. That means it dropped a huge chunk of ice into the bay. Everybody ran down the hall. We crowded around the door. We looked out and watched the waves come by. It was a big deal. When I was at Palmer this last March, this was happening 4 or 5 times a day. The glacier behind the station has become so much more active. It is breaking apart. It is receding, just as 87% of the glaciers along the western Antarctic Peninsula are. So, we have really good information about the Mar Glacier because we're so close to it. And one of the things that we do to measure the amount of recession is we send a scientist out every couple years, and in this picture, it's a she. She's wearing a backpack, and she has a GPS unit talking to a satellite over her, and she goes for a hike. And she hikes all day along the leading edge of the glacier. And in the next picture, you can see a map. You can see where the last line was drawn in 2017. And you can look over to the left and see where the glacier was in the 1960s, or that little picture of my colleagues, Chuck and Maggie Amsler, in the mid-70s, when you could open the door of the station and almost step onto the glacier. You can also look at the glacier from the air. You can see here in the yellow line where the glacier was in 1975, and then look where it was when this picture was taken in 2013. There are other ways to look at glaciers, and it's possible now using techniques from satellites, special instruments that measure glacial thinning. And this is the areas of Antarctica where you can see the glacial thinning. You can see the red-orange colors mostly on the west side of the continent and up along the peninsula. And then look at Greenland in the northern hemisphere as well. Lots of melting. And then this was a surprise. Scientists didn't realize that the Thwaites Glacier on the western side of Antarctica was undergoing a tremendously rapid recession. We're talking about kilometers of recession between the early 1990s and around up to about 2011, and it continues today. The concern about this glacier is that it's sort of metaphorically a cork. It is the point at which the western ice sheet, the ice on that portion moves out into the ocean. So it is where the ice moves off the land. And the concern is that with that glacier disappearing, the rate of flow of ice off the continent of Antarctica could be accelerated. Remember, there's 2 or 3 miles of ice deep sitting on top of Antarctica. So what does that mean? It means that when you have ice coming off of the land and entering the ocean, you contribute to sea level rise. And that is taken into consideration when scientists calculate how much sea level rise will we have here on the coast of Alabama. It's actually tied back in some ways to Antarctica. Now, this is a map that shows where ice sheets have been breaking up over the last 30 years. I want to show you a couple of them. So this is a picture that shows the Larsen B ice shelf. You can see it over on the right side of the peninsula. Let me show you a picture that was taken of the Larsen B ice shelf on January 31st, 2002. Scientists noticed that the ice sheet was beginning to break up. There were lines running down the length of it, striations. So they came back a month later, and the entire Larsen B ice shelf was disintegrating. In fact, 2 weeks later, it went out to sea. Now, just to give you a sense of the magnitude, the ice sheet itself is about 1,000 feet deep. It's floating in the ocean. And this is a piece of ice the size of the state of Rhode Island that broke out, about 5,700 square kilometers. Now, you also might have heard in the news a few years ago, about 3 years ago, that the Larsen C ice shelf was beginning to break up. And you can see that little section of it, and it actually floated out to sea on July 12th, 2017, that little orange section. At that time, it was one of the largest icebergs that had ever been recorded. It was an iceberg the size of Delaware. And then lastly, I want to take you down to the Wilkins ice shelf at the base of the peninsula. And here you can see an area that has been disintegrating for quite a period of time now, all the way back to 2009. It still hasn't quite broken up. It's dangling to some islands, but eventually it will. And when that disappears, it's a piece of ice the size of Connecticut. So what does this mean? Well, there's good news in that this ice, the ice sheets, are already in the ocean. They're floating in the water. And these 1,000-foot thick ice sheets, when they melt, have no effect on sea level rise because they're already in the ocean. It's the same idea as if you had a glass of ice water. When the ice melts, the water doesn't come over the top of the glass. But there is a little concern because these ice sheets have been shown to be barriers to the movement of ice off the continent and into the ocean. So when the ice sheets disappear, the rate of flow is increased, and that does affect sea level rise. So these are some things that are happening with the physical environment, the ice that's so much of Antarctica, that omnipresent ice. But as a marine biologist, I'm interested in the life, the tremendous plethora of life that lives on the Antarctic continent, and especially along the Antarctic Peninsula. How are these organisms being impacted as those very rapid changes in the climate are occurring, as it's warming so quickly? Well, let me tell you first and most about the penguins. This is the Adelie penguin, and the fellow in the back of this image, Bill Fraser, is a good friend of mine, and he went down to Palmer Station way back in the 1970s as a graduate student, and he tagged 16,000 breeding pairs of Adelie penguins. Now that's a doctoral project. Bill came back. He's come back every year for over 45 years to visit his colonies and to follow those penguins to see how they're doing. Let me tell you, it's not a good story for the Adelie. The Adelie is the one in the top left-hand corner. Looks like Charlie Chaplin. Got a little tuxedo on. And that purple line is the population of Adelies declining over that period of time that Bill has been following them. In fact, he told me fairly recently that he's down to about 1,000 or so penguins. So we're talking about 90% plus of these Adelie penguins have disappeared. And we know they're not moving to other places because we never find the tags there. Now, interesting, at the same time, the penguin on the top right, the chin strap, showed up, and there are now small numbers, maybe 300-400 pairs, and more so, the penguin in the middle picture, the Gentoo, has really shown up. You can see that in the orange line. There are now several thousands of breeding pairs of these Gentoos that are moving there. So what's going on here? Well, the Gentoo and the chinstrap penguin are warm weather penguins. And as the peninsula is rapidly warming, they're extending their range down the peninsula and occupying places that they didn't live before. So you have sort of the Adelies disappearing and these others appearing. So let's look and see what happened to the Adelies. And this is Bill Fraser's hypothesis. One of the things is that, ironically, as the Antarctic Peninsula is warming, it's getting more humid. The air is thicker than it used to be. There's more snowfall. It's snowing later than it used to. So the Adelie penguins come in, and they're genetically programmed to lay their eggs at a particular time, and then along comes these unseasonably late snowstorms and bury the colony. And very sadly, the eggs don't survive that burial of snow when it melts. The other thing that's affecting the Adelie, Bill believes that the sea ice serves as a platform for the Adelie penguin to toboggan across on their little bellies and get out to the edge of the ice to feed on krill. And krill are those little shrimp that are the quintessential base of the Antarctic food web. So sea ice, which is only 3 to 5 feet deep, doubles the size of Antarctica in the winter, disappears in the summer, is important for a number of marine organisms. They have become dependent on sea ice. So as the sea ice is being depleted by the warming, the Adelies now have to swim much further offshore to get to their food than they used to. And Bill thinks that that's making it tough for them to raise their chicks. Now, that sea ice is important for a number of reasons. And one thing that's been discovered is that krill, those little shrimp, live under the sea ice when they're teenagers. And they're feeding on little tiny plant cells called diatoms. So as the sea ice is disappearing, the krill populations could be affected as well. So that's another relationship. And if you have trouble with krill populations, there's lots of organisms that could be impacted. For example, the baleen whales that feed on krill. Now, I'm going to give you some good news about whales, though. Whales in Antarctica are doing really well. I counted over 75 humpbacks in a single afternoon, not just a couple years ago. The theory is that whales in Antarctica are coming back from the hunting that occurred centuries ago, and effectively they've hit this point where the populations are doing very, very well. For now anyway, they're doing great. Other organisms that could be impacted by the loss of the sea ice include this beautiful seal. It's my favorite seal in Antarctica. It's called the Weddell seal. And if you look at the picture up on the right, you can see it's got unique teeth. The female Weddell seal has ice-chipping teeth. And she looks for a little hole in the ice, and she drills away with it, her little teeth, until she gets a breathing hole. And then she keeps working until she can climb right up through the hole in the sea ice and give birth next to the hole. And what does that buy her? Protection. The leopard seals, the killer whales, can't get to her and her pups. And it's all because of her dentition. So she's dependent on the sea ice. I don't think the Weddell seals will disappear. I think they'll probably follow the ice as it retreats. The leopard seal, the mighty leopard seal, 10 feet long, 1,000 pounds, the top predator in Antarctica, a species that when we see one, and the divers are down below in the water, we actually have a siren that we drop into the water and set off to tell the divers that a leopard seal has been spotted. And the divers will come together and wait for a clear time and then come zooming up out of the water, and we leave the leopard seal to the water that day. Leopard seals are beautiful animals, but nobody has ever seen a leopard seal give birth anywhere except on an ice floe. So as the ice disappears, nobody knows if leopard seals in Antarctica will go to shore and give birth on land. They may very well, but we just don't know. What about the tiny things in the water? The little things that we call plankton, the tiny little phytoplankton, the zooplankton. Well, the guy here in this picture with the white hat is a good friend of mine. His name is Hugh Darlow, and he, until very recently, was the director of the long-term ecological research program that's been looking at plankton populations up and down the Antarctic Peninsula for over 30 years. And I gave Hugh a big task. I said, Hugh, I need one slide that summarizes your 30 years of data. And he gave me a pretty good slide. It's not this one. This is the one showing the track of the ship that goes along the peninsula where they do their sampling. But in the next slide, you can see what he sent me. What you're looking at in the top two cartoons is comparing the 70s and 80s with the 90s and 2000s in terms of these plankton populations. The top two cartoons are for the tip of the peninsula, and the bottom two cartoons are for further down. So what's happening over this period of time? Well, first of all, in the biggest picture, the peninsula is changing from a polar climate to a warmer, humid, sub-Antarctic type of climate. And if you look specifically at the things that are happening, the weather is changing. It's windier than it used to be. It's cloudier. And that wind is churning up the surface of the ocean and pushing the phytoplankton deeper where they're having trouble getting enough light for photosynthesis. So some of the phytoplankton, the big juicy ones, are disappearing, and the krill aren't doing quite as well. What's happening further down the peninsula is not quite as dramatic as that, but Hugh thinks that it's probably going to eventually change. So what else might happen as it warms? Well, you know, there are forests in Antarctica. Did you know that? There are forests in Antarctica. People don't realize that. All you have to do, put on your dry suit, grab your scuba tanks, and slide into the water in front of Palmer Station, and you will be swimming amongst a forest of about 150 species of seaweeds. Some of them will tower over your head, 20, 30 feet above you. Some of the blades are 10 feet long. Well, I think that these forests probably will do very well in a warming Antarctica because the sea ice will no longer be above them, so they'll have more light. They'll probably grow deeper. They might extend further down the peninsula. But we also know that these seaweeds, from work that we've done in our own labs, have chemicals in them that defend them from little predators, little crustaceans. And as more energy is available from more light, those chemicals that are produced could be changed, or maybe there's more of them, and that could affect the food web, who eats who. And so there could be yet effects. What about the offspring, the larvae of sponges and soft corals and starfish and sea urchins? You are looking at a picture of a larval starfish, a little baby starfish. We know from work that we've done and others have done that if you collect these larvae and bring them in the laboratory and warm up the temperature just 2 degrees, those little larvae develop much more quickly than normally. They're very temperature sensitive. So that might be good. It could be that they spend less time in the water swimming around where they could get eaten. But it might also be a problem because many of these larvae feed on phytoplankton. And in Antarctica, the phytoplankton appear at a very distinct time. So what if they show up at the cafeteria and the door's locked? In other words, they're offset from when the food becomes available. That could be a very challenging issue. What about range extensions? I already told you there's the Gen 2 penguin, remember? the chinstrap penguin, are moving in. They're extending their range. Well, this seal in the top left image, the elephant seal, has also moved down the peninsula. And they've been there for quite a while now. They have a breeding colony not too far from us. And the Antarctic fur seal, the one in the bottom right image, is also moving in. They haven't established a breeding colony, but they might. So these are species that are moving in now that it's warm. All right, let me tell you about one that's a little more striking. I'll set the stage by showing you this picture of the ancient seafloor of Antarctica. That's right. The community in the seafloor of Antarctica really began to be established about 40 million years ago when Antarctica separated from South America, and that big giant current I mentioned, the Antarctic Circumpolar Current, began to really move around and locked Antarctica into a deep freeze. And many species had to adapt to the cold, or they didn't make it, they went extinct. And many other species have become species in Antarctica. They have evolved there over time. Now, there are some very conspicuous things that you do not find on the ocean floor of Antarctica. There are no sharks. There are no fish with crushing jaws. All 250 species of Antarctic fish are wimps. They have weak little jaws and they feed on little crustaceans. There's nothing with a claw. There's no crabs. There's no lobsters. So the species that live in this community have never encountered a crushing predator, something that could crush their shell. So you can pick up an Antarctic clam and you can take 2 fingers and you can generally just crack the shell with 2 fingers. Things are very weakly calcified. So, given that setting, you can imagine the shock of my colleague, Sven Thatchy, who was 1,100 meters above this picture in 2007. And here is his remotely operated submarine picking up one of 13 king crabs on the Antarctic slope, marching up the slope. Well, this was a shock to scientists because they thought that king crabs could not move up onto the slope and up to the shelf of Antarctica because they don't do well in cold. In fact, if you lower the temperature to a certain point with crabs, they fall over. They miss their mouth when they feed each other. They're narcotized. It's like a narcotic. And so they were kept from going up the slope, in theory, by their inability to survive these very low temperatures that occurred there. So now that the deep Antarctic current is beginning to warm, maybe we'll have king crabs moving in. Well, I wrote a grant proposal with Rich Aronson, who's at the FIT, Florida Institute of Technology, and we sent it off to get reviewed. Meantime, because we wanted to look for those crabs. Meantime, this colleague of ours discovered 1.5 million king crabs living in a very deep canyon near Palmer Station. They weren't up on the slope, but they were poised. So we were lucky, we got funded, and we've had 3 cruises to Antarctica, and we lease a submarine from Woods Hole, and we tow the submarine up the Antarctic slope and onto the shelf in 8-kilometer-long transects. And on the front of this submarine are cameras taking pictures about every 5 seconds. So you can imagine how many pictures we get from doing these transects that go up the slope and onto the shelf. I think we had close to 100,000. And when you have that much data, when you have those numbers, you use a very important tool that scientists take advantage of. It's called the graduate student. So we had our graduate students analyze all that data. And the crabs are there. They're on the slope, probably in the millions. But the good news is they have not reached the shelf yet. So we're hoping that they won't. But we're going to try to follow that. And then last but not least, I have to mention ocean acidification. So this is when we produce carbon dioxide from burning fossil fuels, and it enters the world's oceans. It dissolves into the ocean. There's a chemical reaction that lowers the pH. It makes it more acidic. So in probably 30 years, the oceans have become about 30% more acidic, or at least since the Industrial Revolution, I should say. So Antarctica is a very important place to study ocean acidification because the ocean is so cold, it absorbs more CO2 than other oceans. So we've had some research projects, not particularly for this species, but I wanted to mention this because it's an amazing story. This is a sea butterfly. It's a little snail that has wings and it flutters in the water. It's about the size of the tip of a pencil and as numerous as the stars in the heavens. And this little sea butterfly you can collect today from waters of the Southern Ocean and see etching on the shell from the beginnings of ocean acidification having its effect. So this is something that's happening now. Well, we did some work looking at various species of snails and crustaceans, exposing them to CO2 levels. And basically what we found so far is there's winners and there's losers. Some species seem to be quite resilient and others are having a tougher time. Here's Palmer Station, where we do our work. I wanted you to see my home away from home, where I've been working the last 20 years. And it's a little station with 44 beds, if you can imagine. 44 beds. That's how many people we have. It's a town, it's a community, it's a family, and it's just a wonderful place, very supportive to do our work. Thank you to the National Science Foundation for that. So this is a list of the things I've talked about with the ice changing, the glaciers, the sea ice, all these variables, and then what's happening with species that are moving in, the potential effects of warming on these communities, and ocean acidification. So it's quite a long list, but I want to show you something. This is what the community has looked like on the peninsula for millennia, okay? See the sea ice, the Adelie penguin, lots of krill, the forests, all being fed by the Antarctic Circumpolar Current, the ACC. And this is where we're headed probably by mid to late century. The sea ice is going to be gone, the Adelie with it. We'll probably have lots of chinstrap and gentoo penguins, not as much krill. We might have king crabs, I don't know, and the forests will have expanded. So this is a dramatic change in the community over a period of a few decades. And that's what's so important about climate change. The climate of our Earth has always changed, but with anthropogenic climate change, with what we're doing, it's changing very, very quickly. And organisms have a tough time adapting that quickly. That's the difference. Somebody asked you, what's the big deal? The big deal is the rate of change being so rapid. So why should we care? Why should we care about climate change in Antarctica? It's a long way from Birmingham to Antarctica. It is. Out of place, out of mind. Well, you can go online and you can Google all sorts of things about Antarctica, but one you might not know is that there are very valuable things under that ice. We have been looking for compounds, chemicals in marine life that could help fight human diseases. And I'll tell you quickly just about a few of them. We discovered or go ahead, this is a collection picture of us getting things for our chemical work, and there's another one, I think we're in a Zodiac coming to shore at Palmer. So, this is a tunicate. This is a type of marine invertebrate, and we found a chemical in it called palmerolide. We get to name it after the station. How cool is that? And it turned out to be very potent against melanoma skin cancer. So much so that the National Cancer Institute was interested in working with it. We found a chemical in an Antarctic seaweed. It's a protein active against the H1N1 flu virus. And we've also found a chemical in an Antarctic sponge we named Darwinolide that has activity against MRSA, methicillin-resistant Staphylococcus aureus. It's that bacteria you don't want to get when you go to the hospital because it's hard to treat with antibiotics. So my point is that Antarctica has a huge library of chemistry over evolutionary periods of time that are very, very long. Why would we squander that? We need to take care of that for future generations. So I used to get asked this when I toured around the country talking about climate change. Is it really warming? I don't get asked that much anymore. Most people believe the Earth is warming. And you can go online and you can Google global warming or climate change, and you can find lots of data to support that. I want to show you the data that convinced me. There is absolutely no way that you can refute these data. You can see that global warming is accelerating very quickly, right? So what I get asked is, do we have something to do with the warming? Is this just a natural cycle, an up and down pattern, and we just happen to be in an up portion of it? And I want to show you a slide that explains what's really, I think, very telling. So don't be intimidated by this slide. You're looking at an ice core. It's laying on its side. The ice core is about the diameter of a grapefruit, and it's about 1,100 meters down through the ice. So the deep end of the core is on the left, and the top end is on the right. And you're looking back through time, because in that little ice are tiny little bubbles that trap the atmosphere at the time the ice was formed. And there's CO2 inside those bubbles. You can measure CO2 over time, and that's what the red line is that goes up and down over the 430,000 years that's represented in that ice core. And the blue line is temperature, and that's calculated indirectly. But I want you to look at the red line, because that's the carbon dioxide. That's the greenhouse warming gas. It goes up and down and up and down. But look what happens way over on the right when we start to hit the Industrial Revolution. The amount of CO2 in our atmosphere shoots. It skyrockets. In fact, this graph is dated now. I think we're up to about, I want to say 411 parts per million. And where that black line is across the graph, you can see it's never been higher than 300 parts per million over all that time. So to me, as a scientist, that's very strong evidence that we're having an impact on the warming that we're seeing. Now, you wanted to know why those red lines go up and down in that 100,000-year period. And that has to do with something that is called the Milankovitch cycle. And it's the Earth's elliptical orbit around the sun in a 100,000-year period that causes that. So, gloom and doom. I want to leave with a very positive, hopeful story. I want to leave you with that sense. So in 1985, there were two scientists sitting at their desk, and they sent the data back to their boss in England, and he sent it back and said, I don't believe it. I'm going to get you a new spectrophotometer. You're going back to Antarctica next year. You're going to take the measurements again. And they did. And they got the same story. And what they had discovered was a massive hole in the ozone over Antarctica. It was so big that the hole actually went over New Zealand at times. This hole in the ozone, this precious part of our atmosphere that protects us from ultraviolet radiation and affects climate, was gone. 2 years later, in the most remarkable thing, 20 countries sat down around a table in Montreal, Canada, and they ratified the Montreal Protocol that regulated the chlorofluorocarbons that were causing the destruction of that ozone. Today, there's 197 countries that are signatories to the Montreal Protocol, and it's worked. Because of the regulation of those chemicals, the hole stopped growing. It's now probably going to shrink and close mid-century instead of end of century. It's a wonderful, positive story. And the companies that made the refrigerants didn't go out of business. They didn't fire their employees. They used innovation to build new molecules that were not destructive. So that's just an example of the kind of thing that we could do collectively, and I hope we do. So let me end by telling you just a few more things about me. So, when I wanted to take this story out to the public, everybody said, write a book. Write a book? So I said, okay, how do I write a book? Well, you need a literary agent. Well, I tried to find a literary agent, and I found out to get a literary agent, you have to have a book. So it's kind of like a catch-22. Now, I was very fortunate because I knew a very famous scientist. His name is E.O. Wilson. He's an Alabaman. He's been at Harvard for 70 years. E.O. Wilson was kind enough to introduce me to his literary agency. And I got my literary agent. I published my book. I had no idea when it came out the things that would happen. The phone rang, and the head of the E.O. Wilson Biodiversity Foundation said, "Jim, we love your chapter on the Adelie penguin. We want to make a little video, 3-minute video. We want to use your wording, your prose. And it's going to go in the zoos and aquariums. It's going to be wonderful." And I thought she was asking me if I would narrate this video. And she said, "No, we'll have Harrison do it." And I said, "Harrison who?" And she said, "Well, Harrison Ford, of course." So you can go to YouTube and you can listen to Ghost Rookeries, Climate Change in the Adelie Penguin, read by Harrison Ford. The other thing that happened to me was I spent a day with Bill Gates, and he was kind enough to read my book before it came out and write a lovely little saying on the front page, the front cover. But the thing I love about the day I spent with Bill Gates was not just his interest in science and his interest in climate change, which he was very much. It was the point where my colleague Chuck Amsler and I took Bill and his father, Bill Jr., Bill Sr., up to the big TV room to watch the NSF video. And in came, we had put them up front in 2 big chairs, Bill and his father. And in came the IT guy, and he could not get Microsoft to boot up. Do you know what that must have felt like? And finally, Bill's father looked at Bill and went, "You need to do something about this." So I thought that was my Microsoft moment. All right, well, what else am I doing? Well, I've been taking people to Antarctica for 10 years now on a cruise with Abercrombie and Kent called the Communicating Climate Change Cruise, and we learn about climate change and we visit the peninsula. It's very, very formative for people. They come back changed people. They really do. And I've also helped host a workshop on spirituality and climate change with Mark Johnson, Episcopal priest, out at Camp McDowell. And for 3 days, we had 50 people representing several different religions, and we talked about climate change. I presented the scientific side, and he talked about the care of creation and how important it is to look at climate change through that lens. And I'm also now the voice of the Nature Conservancy's Can We Talk Climate campaign. Okay, it's a campaign, no money. You just pledge to talk to one person within a week about climate change. We need to talk more about climate change as Americans. And then I'll finish up with a final story. And this past year, I was very honored to go up and be given an Antarctic Medal, or Service Award, I should say, by the Explorers Club. And the real honor for me was not the award as much as the fact that there were 8 Apollo astronauts that shared the stage that evening in New York City. And at the end of the evening, the last in the row, Rusty Schweickart, one of the pilots from an Apollo mission, he stood up and looked back at all the other astronauts, and he turned to the crowd and he said, "You know what? We have all been up in space. We have all looked back at this beautiful Earth. We have all realized how fragile and delicate this place is, and we need to take care of it." And I thought it was just a very appropriate end to the evening, and in a bigger picture, something that we all need to think about. So thank you so much.
Thank you so much, Dr. McClintock, for coming and being with us tonight. And we may have a few questions for you and want to tell people, I better keep my distance, but if you want to ask a question, you can email me at lmichael@southhighland.org, lmichael@southhighland.org, or if you're in the streaming, you can post a question on there. And we'll do a little chit-chat, maybe give people a chance to do that. But we do have one question that has come in already, and this is from Deborah Charcois, and this is the question. Dr. McClintock, Loss of permafrost seems to play a role in the effects of climate change in the Arctic. From your perspective, would loss of permafrost be a significant factor in Antarctica in the future?
That's a great question. I actually met a group of scientists in Antarctica that were studying permafrost in Antarctica. And what I learned is that while there is permafrost in Antarctica, there's not nearly as much as you find in the Arctic. So the potential role of permafrost in affecting the global climate from the permafrost in Antarctica is much reduced compared to the Arctic. The concern about melting permafrost, particularly in the Arctic, was the release of methane gas, which is a very potent greenhouse gas. So the answer to the question is yes, Antarctica has permafrost, but it's not a major player in the models for warming.
Can you explain a little bit about permafrost?
Oh, permafrost is essentially the frozen top level of the soil. Okay. So in the Arctic, you may find the top 10 feet of the soil is essentially solid, just below the level of the vegetation. It's called permafrost. Yeah.
Now, you've been to Antarctica quite a few times.
Mm-hmm.
So one of my questions on a personal level is, what was the biggest challenge for you personally being there?
I think the biggest challenge over the years has been leaving behind my family when I go to Antarctica. And what helped over the years was that when I first went to Antarctica, I literally was using the equivalent of Western Union telegrams. And now when I go to Antarctica, I can pick up what's called what they call a computer phone. It essentially looks like a cell phone.
Yeah.
I can hike up behind the station on top of the glacier. I can open up the phone and talk to my wife, and it's like she's standing right there.
Wow.
There's hardly even any delay.
Yeah.
So the technology has really helped with that.
That's amazing.
Yeah. So I would say that that's the biggest challenge. Is being away from friends.
Are there
and family.
particular physical challenges in that climate?
When I worked at McMurdo Station for 10 years, which is much further south and much colder, yes. The physical challenge there was that the air was so dry that your skin had to adjust to it. You'd get cracking lips and things like this. The other thing was that it never got dark when I was there. So you had to be careful that you went to bed at the right time and got up at the right time in the morning and kept up with your exercise. Because otherwise, if you just binge work, which scientists are known to do, you can stay up for 3 or 4 days and then sleep for 20 hours. That's not healthy, though. Your immune system doesn't do well under those conditions. So there is some physical issues. The other thing is you just have to be careful in Antarctica. Even at Palmer Station, the weather can change very quickly. The wind can come up, the visibility can go down. If you're out in a small boat, you have to be very aware of what's happening. If you're at McMurdo and the snow comes in, theoretically, you could wander away from a building and in a whiteout have a hard time getting back. So you have to be cognizant that Antarctica always has the last word.
What would be the highest temperature at Palmer Station?
I think the record is up in the mid-40s now, something like that. And there was a record broken further up the peninsula, I think it was in the 50s, not too long ago, in Fahrenheit.
And the coldest?
The coldest at Palmer is not particularly cold compared to McMurdo or the South Pole. I would say 30 below, something like that. Cold, but not the 60 to 70 below that you find at McMurdo or the 100 below that you find at the American South Pole Station.
Do you have physicians there in case someone gets ill?
Yes, we do. We have a physician at Palmer. There are several physicians at McMurdo, a bigger station, and at the South Pole. And we have a nurse, so we're in good hands.
And if you had something traumatic happen, you could get home in...
It's tough. At McMurdo, you can get home because the planes fly in and out. There is no plane coming to Palmer. There's no runway that's safe. So typically it means that you would be put on the nearest ship that they could bring in. You would be taken up the coast, about a day's cruise, to an island, King George. and you would be flown from there in a medical evacuation, probably by a C-130 to Chile. That would be the nearest hospital. So you're looking at probably 3 or 4 days.
Well, it would seem to me that when you go down there, you need to have some prayer warriors back home.
You do.
Pray that everything goes all right.
Yes.
While you're away.
They have a lovely little church at McMurdo. I think it's called the Church of the Winds. But it's interdenominational, as you might imagine, for a population of 1,000 people. But yeah, it's very nice.
I have a question to ask. It's somewhat scientific. I was a microbiology major in college and have done nothing with it. I went into the ministry instead, so right. When I graduated from seminary, I said I was qualified to convert germs. But my question is related to microorganisms. Is there pathogenic organisms there, as well as those that are positive and
Yeah, I plead innocent. I'm not a microbiologist, but I think that there are some pathogens. There are some things that have gotten into the penguin colonies that have been pathogenic. Human pathogens only within the confines of the station that I know of, yeah. Yeah,
that's interesting. Daniel, here's a question from Kathy Tracy. She said, you showed us how some species in Antarctica seem to benefit from the warming. Could you envision some locations in very cold climates actually welcoming climate change? That's Jerry Tracy. That's from Jerry Tracy. Okay. Weatherman, Channel 13.
Oh, okay. In the big picture, I don't think so. There are going to be some winners in terms of species, but I think they're going to be fewer than the ones that are paying the price. Yeah. But there will be, species move if they can, if they're not plants or sponges and things like that. So as Alabama is warming, things are moving up north following the warming trends. So you will have movements of species and those species that follow can migrate, can do fine. So there is not necessarily a negative to that. But in the big picture of global climate change, the numbers of species that we're losing is really quite dramatic.
I guess another question is, when is your next trip to Antarctica?
I might be going this January. It's possible, but that may be canceled or delayed because of COVID. So that would be, and then I have another trip scheduled in December of 2021. Right. So probably, most likely, I'm going to guess in about 1.5 years. Yeah.
I saw the cruise ship on there, and we know what the situation is now with the cruising industry, but is that a cruise that you would recommend to Antarctica?
Would I recommend this cruise? This is the epitome of the ultimate cruise. And I say that for many reasons. When you go to Antarctica on a cruise like this, it changes you. You come back a different person. You have no idea how beautiful, how grand the landscapes are in Antarctica until you're actually physically there. And you take that grandeur and you take that incredible scale of distance and you combine it with one of the most abundant wildlife populations anywhere. So you're standing on the bow of the ship, you're looking off at mountain ranges that look like you could touch them and they're hundreds of miles away. You're looking down and you see a group of humpback whales coming up through the water. There's penguins porpoising along. It's just absolutely stunning. It really is. And these cruises, including the one that I do with A&K, have excellent lecturers on board. So you're learning history, you're learning marine biology, you're learning climate change, you're learning geology, and people just love it. I can't say enough about these cruises. Put it on your bucket list, really. You should.
Well, our pastor's here tonight, and maybe we can get Ed to help organize a cruise to Antarctica. And I'm going to ask you to come up and do a closing prayer for us, Ed, if you will. One other question while he's coming. Are you able to interact with the animals there?
Yes, I get such a kick out of it because they tell everybody on the cruise before you go to shore, remember, you got to stay 15 feet from the penguins. That's the Antarctic Treaty guideline. They're very strict. What they don't tell them is as soon as they get to shore, the penguins come right up to you. They have no fear whatsoever. And that's really very typical of Antarctic wildlife. They completely have no fear of humans. And so you are interacting. You sit quietly and the penguins come streaming by 3 feet in front of you. You have to keep a little distance from the seals. Yeah. But yeah, it's wonderful for wildlife observations. Yeah.
That's awesome. Well, thank you again for
My pleasure.
What a stimulating discussion, and something that we all need to pray about and think about. You have a quote, I think, that you've used that we can't solve problems if we can't communicate, or something like that.
Right.
Talk about them.
Yeah.
And unfortunately, we're living in an age where people are scared to death to talk about so many things.
Yes, I agree.
Because of divisiveness in our culture. But
Yep.
I hope we can talk more about this. And thank you.
I do too. Thank you
You've helped
so
us
much.
in that way.
Thank you, Larry.
Indeed, thank you, Dr. McClintock, for being with us tonight and for the amazing work you've been doing for, 30 plus years. Amazing. And thank you all for joining us and being a part of this, we hope will be periodic midweek lecture, talk, different topics along the way. Some of you may want to also, in terms of the cruise opportunity, speak with Neil Davis, our good member Neil Davis, who was on the last cruise with Dr. McClintock. And I'm sure, I've heard from Neil. I know how excited and how indeed he was transformed by that experience. Let's pray together. Blessed Lord, we give you thanks and praise for your goodness, your mercy, and your love to us. We ask that you would help us as we seek to learn and grow about your creation and to be good and better stewards of that which you have entrusted to our care. We thank you for this time tonight, for the things we've learned. We thank you for this good earth that you give us to inhabit for our brief time here. Help us as we seek to look after it and for children, children's children, and future generations. To you, O God, be all honor and praise and glory through Jesus Christ our Lord. Amen. Thank you.